This is the last part of your daily work for 4.2. They give you functions that are already one-to-one. You have to find its inverse, check your answer, and then state the domain of f and find its range using f inverse. So I thought I would do these 4 problems here, and you can do the evens in class. Okay, the first one is 59, and again we're going to do the same thing we did before. We're going to write this f of x in terms of y, so y equals 2 over 3 plus x. We switch the x and the y, and then we solve for y. And the way you solve for y is we're just going to cross multiply here. So we get x times 3 plus y equals 2. Distribute. We get 3x plus 3y equals 2. Don't forget we're solving for y, so I'm going to subtract the 3x from both sides. So we get 3y equals 2 minus 3x, and then I divide both sides by 3. So you get y equals 2 minus 3x over x. Okay? Now, we know here the domain for f is x, but x cannot be what? Negative 3. And the domain for f inverse is x, all reals, but x cannot be 0. Now we have to verify, and we're dealing with rationals here, so it's a little tricky here. So we're going to compose f, so this is verifying. We're going to compose f with f inverse of x, which equals f of 2 minus 3x over x. So basically what we get, and it helps if you've written some of this down, we're going to get 2 over 3 plus your x, which is this portion. So that's going to be 2 minus 3x over x. Now, the little trick here, what we're going to do, because we have all this stuff going on, what we're going to do to get rid of this x is we're going to multiply the numerator by x and the denominator by x. When you do that, you're going to get 2x, and here these two will cancel. So then we're going to get 3 plus 2 minus 3x. You're going to simplify, and you're going to get 2x over, what happened here? So we had the x here. Oh, this should have been this cancels here, but you get an x here. So this is going to be 3x here. 3x. Basically, when you're multiplying the denominator by x, you're multiplying this piece by x and this piece by x. So you're going to get, these two will cancel here, and you get x. Okay, we have to do it the other way as well. I'm going to try to do this on one page here. So I'll do it here, and we're going to compose f inverse with f of x. So we get f inverse of 2 over 3 plus x, which gives us 2 minus 3 times 2 over 3 plus x over 2 over 3 plus x. Now we're going to do the little trick again. We're going to multiply this whole thing by 3 plus x, and also the denominator by 3 plus x. When you multiply this, you're going to multiply this and this, so you're going to get 2 times 3 plus x minus 3 times 2, because in this case these two will cancel, but make sure you multiply it here over 2, because this will cancel here. You clean it up, you're going to get 6 plus 2x minus 6 over 2, which gives you x. Now, we have to talk about the domain. The domain of f equals of f. Write this a little better. Domain of, let me do it in a different color, f equals the range of f inverse. So this equals all real numbers, but x cannot be -3. And we saw that from the very beginning, right here. That equals your range. And remember what this was here. Okay? And then for your range of f, equals your domain of f inverse, which means all reals, but x cannot be 0. Okay? We'll talk about this more in class as well. Okay, the next problem is going to be 61. We have f of x equals 3x over x plus 2. We change this to y. Switch the x and the y. And then solve for y. So we're going to cross multiply. We're going to distribute. And solve for y. So in this case, what I'm going to do is keep my y's together. So I'll get 2x equals 3y minus xy. And, sorry, this is y. I'm going to pull out a y here. So I get 3 minus x equals 2x. So I have 2x over 3 minus x equals y. Basically, I just divide up both sides by 3 minus x. So that's your inverse. And let's notice that the domain of f equals all reals, but x cannot be -2. That means that's the range of f inverse. The range of f inverse is y such that y cannot be -2. Alright? And domain of f inverse is x such that x cannot be 3. That means the range of f is y such that y cannot be 3. Because these interchange with one another. Okay? Now, we have to verify this. So basically we're going to verify that f composed with f inverse of x equals f of -2x for x minus 3, which equals 3 times -2x over x minus 3 all over -2x over x plus minus 3, sorry. Plus 2. Now again, I'm just going to multiply the numerator and the denominator here by x minus 3. And that leaves me with 3 times -2x because these two will cancel here, over negative 2x plus 2x minus 6, which gives me negative 6x over negative 6, which equals x. Okay, and then the other way is going to be f inverse composed with f of x, which gives me f inverse of 3x over x plus 2, which equals negative 2 times 3x over x plus 2 over 3x over x plus 2 minus 3. Again, I'm going to multiply the numerator and the denominator by x plus 2. Multiply each part, and you're going to get negative 6x over 3x minus 3x minus 6, which gives me negative 6x over negative 6, which equals x. Okay? Now let's just do one more. They're all basically the same kind of thing. Let me look and see if there's one that's a little different. Let's try 65. So I'll do 65 and that'll be the end of this, okay? So 65, we have f of x equals 3x plus 4 over 2x minus 3. Okay? Right away we know that the domain of this, of f, is x such that x cannot be, x cannot be 3/2. That means it's the range of f inverse, which means it's y such that y cannot be 3/2. Now let's find, that goes with this piece. So let's find the inverse. We switch, we set it to y. Switches the x's and the y's. Cross multiply. You're going to get 2xy minus 3x equals 3y plus 4. Group the y's together. So I think I'm going to put the x over here and the y over here. So I'm going to put my y's on this side just to be different. Pull out your y and you get 2x minus 3 equals 3x plus 4. So y equals 3x plus 4 over 2x minus 3. Now what you'll notice is f and f inverse here are the same. Okay? So basically our domain and range will be the same. So the domain of f inverse is the same as this. You can just copy it down twice. We do have to verify, so that's the hard part, and that's what I wanted to show you on this. So when you verify, you're going to verify f with f inverse of x, which is f of x over x plus 2. Which is actually not right. So it's f of what? F of 3x plus 4. Sorry about that. 3x plus 4 over 2x minus 3, which gives you 3 times 3x plus 4 over 2x minus 3 plus 4 over 2 times 3x plus 4 over 2x minus 3 minus 3. Now what we're going to do here is multiply each piece by 2x minus 3. So when you do that, this part will, these two will cancel, but you have to do this. So it's going to be 3 times 3x plus 4 plus 4 times 2x minus 3. Because you have to distribute here. All over, we're going to do it again, 2 times 3x plus 4 minus 3 times 2x minus 3. Okay, you clean all that up, you're going to get 9x plus 12 plus 8x minus 12 over 6x plus 8 minus 6x plus 9, and that's going to yield 17x over 17, which equals x. Now, I'm going to let you do f inverse of f. Why do you think I'm going to do that? Don't forget that they're both the same, right? So you should get the same information there. Okay, can you see the hard part on this is going to be doing this algebra stuff in here. But that is all of that, and then we're going to be moving on for the next video to 4.3.